Okay, so today's lesson is 5.1b, and we are on part 2 in our study of graphing rational functions. Your objective today, you will be successful when you can use asymptotes and a graphing calculator to sketch a sketch. Okay, let's fix that up. To sketch a rational function. All better. Okay, so let's talk about what's critical to remember from the last lesson, and here is what we need to remember. We look at the numerator, the degree of the numerator and the degree of the denominator to identify the horizontal asymptote. And we factor if possible, to find the vertical asymptotes. We also use the factored version to find the zeros and any possible holes that could occur if we in fact can simplify the fraction when we factor it, or the rational function when we factor it. Also remember, from the original function before it's factored, we can find the y-intercept. Again, this is from the original form before factoring, by just looking at the constant over the constant. Okay, so those are things to remember, and I think we color-coded those, so I'm going to go ahead and highlight those in the colors that we're looking at. So a horizontal asymptote, we do degree over degree. We factor to find our vertical asymptote, zeros and holes, and I do that in red. And then in purple, that's actually, let me go back, zeros are not red, zeros, we do our zeros and our y-intercepts in purple, and that was not a highlighter, so let's try it one more time. Our zeros and our y-intercept, we do those in purple. Okay, so that's what's old. Let's talk about what's new. Okay, so what's new is we will be using the calculator to find values. Near the asymptotes. You know what? Let's just say the vertical asymptotes. So we can see what to find values. So we can see their behaviors. So we can see, we can spell words here. We can see the behavior of the graph. What is it tending to do as we near the asymptotes horizontally or vertically? Okay, and then the other thing that we want to look at today is just some new notation. I don't know why I repeated that, but here we go. So if you see this notation, as x approaches some number, some constant or some value, an asymptote from the left, you'll see a minus sign following the value or the number that you're plugging in. So that says as x approaches c from the left, and then you'll say y approaches. Typically it'll be approaching infinity, or it'll be approaching negative infinity. It could approach positive or negative infinity. If you see it say as x approaches c from the right, that just means you're coming at the asymptote from the right side instead of the left, and you will again see y is approaching positive or negative infinity. Hang on. And so those are the notations that you'll see. And this is as you approach. That's on the approach of a vertical asymptote. That's the notation that we'll be using on the approach to the horizontal asymptotes. we'll see this kind of well, you can just reverse it. You can say as y approaches c from below, x will approach positive or negative infinity. And that shouldn't say -1, it's just c from below. And then as y approaches c from above, x can approach positive or negative infinity. So that's the new notation that we're looking at. So you'll get used to it the more you practice it. Don't be afraid of it. All right. Okay, so here we go. Sketch a graph of the function f of x equals -2x squared plus 2x plus 12 over x squared plus 3x plus 4. So let's keep it in its original form and get the information that we need from that. So we can look at our horizontal asymptote here, and that's coming from a degree of 2 over a degree of 2. And if you remember, if the numerator and denominator have the same degree, then you just divide the lead coefficients to get your horizontal asymptote. So -2 over 1 is -2. So we'll go to our graph and we'll quickly sketch y equals -2. All right, and we got that great information. Switching to our purple pen real quick, let's go ahead and get our y-intercept as well. Remember that in original form, y-intercept, you're just plugging in 0 for all the x's. So basically that just leaves you with the quotient of the constant. So the y-intercept is plugging in zeros. We get 12 divided by -4, which is -3. So we'll come down here and put a y-intercept there at -3. Okay, so that's all the good information we can get from the original form. Let's go ahead now and factor it out so we can get our vertical asymptote and then our zeros. So we're going to start with the numerator. I'm going to go ahead and factor out that lead -2. Well, because they do have a 2 in common, we can factor out -2. All right, so that leaves us with x squared minus x minus 6, which we can fully factor to -2 times x minus 3, x plus 2, all over. Well, I'm just going to take this one all the way over here because it's going to factor right away to x plus 4 and x minus 1. So let's take a look at that for a minute. We don't have any common linear factors, and so there are no holes in our graph. This will be our factored form. So let's take a look now at our vertical asymptotes. Those are our restrictions for our denominator. So x equals -4 and x equals 1. And then let's find our zeros. So switching to purple, we'll look at our zeros. Those are coming from our numerator. So our zeros are 3 and -2. So those will be our x-intercepts. So let's graph those, 3 and -2, and then I'll go grab my red pen and we'll graph our vertical asymptotes at -4 and 1. All right, so there we have that information there. Okay, now we're going to go ahead and make a table of values really quickly. And let's pick some values to plug into our graphing calculator. So we'll go to the left, all the way to the left. So I say let's just pick a -100 and see if we'll get below -2 or above -2 as an output. And that'll give us our negative infinity tendency. Then let's approach x equals -4 from the left, so -4.001. Just approaching it. We could get closer and closer toward 0.00001. However, I think this will give us what we need. Then let's approach it from the right. So we'll approach it. We'll go from -3.999. All right, and then we can see that we've got some good values in that center between the two asymptotes. So we'll just go ahead and approach the other asymptote 1 from the left. So let's use let's 0.999, that'll work. And then we'll also approach it from the right to see what's happening there. It looks like it's going to be above the horizontal asymptote, but we'll check anyway, so we'll go at 1.001. And then the last thing we need to do is just see what we do as x gets extremely large. So we can plug in 100, we could plug in 1,000, we can plug in 1,000,000. Let's get our graphing calculator out and punch this equation in, and let's see what happens. Okay, so we've got that all queued up. I'm going to plug in -100 and I get -2.08. So it looks like we are coming at the horizontal asymptote from below -2. So we can say that this graph is going to be approaching the horizontal asymptote from the bottom. And then let's see what happens when we plug in a -4.001. I'm seeing oops, that was my eraser, -5,602. So it looks like the closer we get to -4, the lower the graph is going to go towards -infinity. So let's stop and just write what's happening and just write a description of that. So as x approaches -infinity, right, y is going to approach -2 from below. Okay, and we could write it as y approaches -2 from below, x approaches -infinity. But now let's go as x approaches, excuse me, -4 from the left. Boy, I got a frog in my throat. Excuse me. So as x approaches -4 from the left, y is approaching -infinity. It's just going to get closer and closer and closer to -4 and down further and further and further. All right, here we go. Let's check -3.999, -3.999. And that's giving me 5,597. And so that means it's going to be way up here, and we can go ahead and graph and come through these points. And I'm thinking that when we look at those, we're probably going to continue to go down forever as we approach x equals 1, but we'll check 0.999 as well. And that gave me -2,401. So it looks as we get closer and closer to x equals 1, we're getting closer and closer to -infinity. So let's go ahead and write that set of behaviors as x approached -4 from the right. We look at that, our y was approaching infinity. As x approached 1 from the left, y was approaching -infinity. All right, excuse me, last two statements and then on to the next problem. Let's plug in 1.001 and I got 2,399. All right, so that means we're going way up high, close to infinity. The closer we get to the asymptote, the higher it goes. And then let's plug in 100 and see what happens as x gets very large. It says -1.992. All right, so that means we're getting really close to y equals -2 from above. And there we go. So let's write that last statement. As x approaches 1 from the right, y is approaching +infinity. And then as x approaches infinity, y is approaching -2 from the top. And that's how I would like to see you write your notation for those kinds of problems. All right, so if we turn over onto the back side, there's two more problems to work on. So you go ahead and press pause and watch the video. Press pause and try the problem out and then come back to watch the video and check your answers. Okay? Okay, so Okay, and there you go. There's the graph as it's complete. I did have to spend a little time looking at what was happening in this section here, because on each, as you approached the -2 from the right and the 0 from the left, they both had the same end behaviors. They were both going down to infinity, so I checked the center between them at -1 right here just to see where to get that really good turning point. So I did that. Okay, and then of course I wrote my finalized behaviors as x is approaching negative infinities or asymptotes. What's y's behavior? Okay, and now we have one more to do. So of course, go ahead and press pause again. Try it one more time, and let's see how you do. Oh, and before you press pause, just go ahead and notice that the graph is not marked with any scales. Find your y-intercept before you make your scale for these graphs. Okay, and so there you see the final graph. You'll see that there's a funky little jump right there as you do cross the horizontal asymptote. When you cross a horizontal asymptote, you'll get over it or below it, depending on what direction you're coming from, just for a little bit. And then you'll just come right back and get really, really close to it as you approach really large or really small numbers. So that happens from time to time, which is why I chose to check -5 to see what was happening there, because I could see at -100 that I was above y equals 3. So I looked around until I found where it crossed, where x crossed the horizontal asymptote. And then I also checked where x equals 1, so -1, so I could see a good turning point for what was happening in between those two asymptotes as well. All right, so your homework tonight, let me look that up real quick. I'll get right back to you. You know what, your homework tonight is to finish up these notes, write a summary, and go back and look at the worksheet that I gave you on Friday and clean up the back, write down this information as it applies to the problems that you sketched for problems 5 through 10. Yeah, I think that would be a really good activity to try for tonight. And tomorrow we'll do an in-class assignment, so you'll have lots of time to practice. All right, have a good one.